Good morning, mathematicians. This is lesson 91, 4.MD.3. Use the strategy, solve a simpler problem to solve area problems. Okay, so here's our problem. Marilyn, that's my aunt's name, Marilyn is going to paint a wall in her bedroom. The wall is 15 feet long and 8 feet tall. I'm going to write this information down. The window takes up an area that is 6 feet long and 4 feet high. How many square feet of the wall will Marilyn have to paint? Well, what's the first thing we know? We know that this is the wall and this is the window. And in order to figure out how much of the wall we have to paint, we need to find the area of the wall and the area of the window, and then subtract the window from the wall, because we don't usually paint windows. Let's try that. Let's do 15 times 8. Do it this way. 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus 4 is 12. Or we could break it down and do 10 times 8, 5 times 8, and do 80 plus 40 to get 120. Whichever way is easier for you to math that. And the area of the window is 4 times 6, and that is 24. Okay? So the area of the wall, length times width, is 120 square feet. The area of the window is 24 square feet. And then we need to subtract the area of the window from the area of the wall. So I would take 120 and subtract 24. So the first thing I have to do is borrow. 10 minus 4 is going to give me 6. 1 minus 2, I'll turn that to 11 minus 2 is going to give me 96 square feet. All right, let's check our work here. Read the problem. Solve the problem. What do I need to find? I need to find how many square feet of the wall Marilyn will paint, right? Square feet Marilyn will paint. What information do I need? The paint will cover the wall. The paint will not cover the window. We talked about this. The base of the wall is 15 feet and the height is 8 feet. We drew that here. The base of the window is 6 and the height is 4. How will I use the information? I can solve simpler problems. Find the area of the wall. We did this first. Then find the area of the window. We did that second. Subtract the area of the window from the area of the wall. So the area of the wall, area equals base times height, 15 times 8, 120 square feet. Next, find the area of the window, base times height, 6 times 4, 24 square feet. Last, subtract the area of the window from the area of the wall, so Marilyn will paint 96 square feet of her bedroom wall. That's exactly what we did. All right, let's take a look at number 1 and 2 here. Ned wants to wallpaper the wall of his bedroom that has the door. The wall is 14 feet wide and 9 feet high. The door is 3 feet wide and 7 feet high. How many square feet of wallpaper will he need? So first we find out the area of the wall. And then we find the area of the door. And that one's easy, so we'll just pop that one in here. So it would be 90 plus 36, right? Let's double check my math because I did that fast. 4 times 9 is 36, carry the 3, 9 times 1 is 9, plus 3 is 12. Okay, good. So then we subtract the door from the wall, because the door is the part we are not going to wallpaper. I don't know why you would wallpaper a door unless you were trying to make a secret entrance. Okay, so 126 minus the area of the door. 6 minus 1 is 5, 2 minus 2 is 0. So How many square feet of wallpaper will Ned need for the wall? He will need 105 square feet. All right, Nicole has a rectangular canvas that is 12 inches long and 10 inches wide. She paints a blue square in the center of the canvas. The square is 3 inches on each side. How much of the canvas is not painted blue? Not painted blue. 20 minus 9 is 111 square inches. All right, I'm just gonna write this out on here because we did the wall was 14 times 9, and that was 126, and then the door was 3 times 7 to equal 21, and that's how we got our answer there. Okay, so on the back side of your paper today, oh, look at this, they even gave you these pictures. Now your copy of this is not shaded. So what I did on my copy is I tried to shade it here. When you look at this on Brightspace, it will be shaded because it's the original copy. This is what yours should look like. So this should be shaded, this should be shaded, and this should be shaded, okay? If you do not shade those, your problems will not make sense. Well, they probably will make sense, but it'll make more sense if those are shaded, okay? All right, happy mathing.